Alright, exercise 41. Let xn be a basis for x. Let an be the span from x1 through xn. Then clearly the union of the an's is x. Each an is closed in x by exercise 18. You can go back and look at that. So now I claim that each an is meager, i.e. it is a possibly countable union of nowhere dense sets. So suppose U is an element sum from 1 to n of, what is this, ak, uk. This is in a n. So this is in an and epsilon is greater than 0. Then the element, let's see here, epsilon over 2 norm xn plus 1. Don't worry, we're not dividing by 0 here because this is a element of our basis. This scalar multiplied by xn plus 1 minus u is not in an. Why is that? We took something in an and we added a scalar multiple of something that's in xn plus 1. But xn plus 1 is a basis vector, which isn't one of the first an basis vectors. And so it's orthogonal, and so it can't be an an, or else xn plus 1 would not be linearly independent from x1 through xn. But what about the distance between these? We know that the epsilon over 2 xn plus 1 times xn plus 1 plus u is in b epsilon of u. And I'm not going to write that out, but what you do is you basically take the norm of this and use less than or equal to, or the distance between this and u is going to be less than or equal to this, the norm of this thing. And this is going to be less than or equal to epsilon. This is going to be equal to epsilon over 2, which is less than epsilon. Why do we need the 2 here? I don't know. Whatever. Epsilon over 2 is less than epsilon, so that's fine. So U has no open neighborhood contained in an. So the interior of an closure, I'm going to combine a few steps here. An is closed, so its closure is itself. So the interior of an closure is equal to the interior of an. And this, because an is not because no point of an has any open neighborhood, this interior is empty. But what does this mean? This means precisely, just by definition, that an is nowhere dense. That's what we mean when we say that a set is nowhere dense. We say that the interior of its closure is empty. That means it's nowhere dense. So x is the union over all n natural numbers n of an is a countable union of nowhere dense sets, and thus by the bare category theorem X is not complete. So I guess so there's no norm on X with respect to which X is complete. I should have said, like, let this be any norm, then we get this construction. But yeah, so let's add that in there. Norm on X. Then you let AN be this, then this is the union, this. Now claim AN is meager. Yeah, and you need this in order, because I put this norm of xn plus 1. What does that even mean if we don't have a norm? So that's exactly the norm that we're referring to, is this particular norm. So X is not complete with respect to the norm given by this. And this completes the proof.